GPU Architecture Series, Episode 1, Why GPS Changed Deep Learning Forever. Imagine you're asked to build 10,000 chairs. You have two choices. The first is a master carpenter. He's incredibly skilled. He can build one chair extremely fast, then immediately move to the next one. The second is a factory with 10,000 workers. Each worker does only one small task, cutting wood, attaching legs, tightening screws, but they all work at the same time. Who finishes first? For building thousands of chairs, the factory wins every time. That's exactly the difference between a CPU and a GPU. A CPU is like the master carpenter. It's designed to complete a few complex tasks as quickly as possible. Modern CPUs typically have 8 to 96 powerful cores with large caches and sophisticated logic to make decisions efficiently. A GPU is the factory. Instead of focusing on a few tasks, it contains thousands of smaller processing cores, organized into groups called streaming multiprocessors, SMs. Each core performs simple calculations, but thousands of them execute simultaneously. Now let's connect this to AI. Large language models like GPT don't think the way humans do. Behind every response, they're performing enormous amounts of mathematics, primarily matrix multiplications. Think of a giant spreadsheet where every number must be multiplied with thousands of other numbers. The good news, each multiplication is independent. That means millions or even billions of calculations can happen in parallel. To understand the scale, a single forward pass for a 70 billion parameter transformer model requires approximately 140 trillion floating point operations per generated token. Trying to perform that workload on a CPU would be painfully slow. A GPU distributes those calculations across thousands of cores, allowing all of them to work together simultaneously. This is why training modern AI models on CPUs could take months or even years, while GPU clusters can complete the same work dramatically faster. That's also why companies like OpenAI, Google, Meta, Anthropic, and NVIDIA invest billions of dollars into GPU infrastructure. So remember this simple analogy. CPU equals few experts solving problems one by one, very quickly. GPU equals thousands of workers solving tiny pieces of the same problem simultaneously. Deep learning isn't just about smarter algorithms. It's about hardware designed to process massive mathematical operations in parallel. And that's why GPS became the engine behind the AI revolution. In the next episode, we'll open up a GPU and explore what's actually inside it, from streaming multiprocessors to tensor cores, to see how these components power today's largest AI models.